Okay, so today class what we're going to do is we're going to work on multiplying polynomials. Okay, so this is going to be a review of grade 9, and then we'll go into the grade 10 level in a second. So we're going to talk about polynomial tiles and how to multiply using them, and of course that will make it easier for our regular multiplication without the algebra tiles. So we're going to practice 2 times 3. So with our 1 tiles, the 1 tiles are the small squares, we'll put down 2 in one of the multiplication places and 3 in the other multiplication places, and those are all perfect squares. So these are our factors. So our factors go on the outside. They are kind of like our dimension of the rectangle. And we are going to find the area of the rectangle, which is length times width. So this is our length, and this could be our width, whatever you want, it doesn't matter. Cool. So then the inside, we retrace the length and the width, and we get 6. That is the area, and that is the product. So last year you talked about factors multiplying to give you your product. So you can say 2 times 3 equals 6. That's your multiplication statement. You get factor times a factor, and that equals your product. Okay, and you've been doing that since you were just wee-high to a grasshopper, in the sense that you were very young when you started learning multiplication. So if we have 2 times 3x plus 1, often multiplication can be referred to as grouping. So this is like 2 groups of 3x plus 1. So we can set up our multiplication grid. We have 2 right here. Then we get 3x, there's 1, 2, 3, all the same perfect rectangles, and then a plus 1. And so here we have our 2 groups of 3x plus 1. Now I just know the length and the width, so I just retrace my lines on the inside, and I then have my 2 groups of 3x plus 1. So the first group is at the top, there's one group of 3x plus 1, and here's the second group of 3x plus 1, your 2 groups. Okay, and so you can have multiplication statement, 2 times 3x plus 1 equals 6x plus 2. So what we have is we have 2 groups of 3x and 2 groups of plus 1. And so you can then, that is called the distribution rule. Okay, and so your distribution rule applies. Here we have 2x times x plus 3. So we have here 2x, 1, 2, and that's going to be multiplied by one group of x. And what happens here is you get these squares because you have x times x. And you have 2x times plus 3, 1, 2, 3. And so then you have your x's in this location, and there you have your 2x times 3. So your multiplication statement would be 2x times x plus 3 equals your product. Your product is always the rectangle that's formed. Your product is 2x squared, those are the big squares, plus 6x. And so what happens when you're multiplying your letters is you get new shapes being formed. You have x squareds being formed and a lot more x's being formed. So let's practice one more time here. 3x times 2 and 3x times negative x. There's 1, 2, 3, and then we have times by 2, 1, 2, and the negative x. Now we have some shading that we've got to be careful of. So again, you could retrace the outside of the shape or do the individual multiplication like I just finished doing. And so then you would have these lines, oops, and these squares would all be shaded in. And those are perfect squares. My drawings aren't that great. Okay, so keep in mind those are all squares. At least that's what they're supposed to be if I could draw properly. And so the multiplication statement is 3x times 2 minus x, and you multiply by each part. There's two different parts to the multiplication. Okay. So when we multiply without tiles, we use arrows to help control our multiplication. So we get 3 times 2x squared, and so it's 3 groups of each. So if you have 3 groups of 2x squared, there's 1, 2, 3. How many do you have altogether? You have 6x squareds. Okay, and so then you have 3 times negative 4. Well, what we can do is just multiply the coefficients. So 3 times negative 4 would be negative 12 x's, and 3 times 7 would be 21. And that is your distribution law. Okay, so you're using your distribution law. Here we have to use a distribution law, but we use a distribution law only with the 3 times the x plus 6. And then we use a distribution law, and you have to include the sign with the 4 for the next set of multiplication. And so you get plus 4 plus 12x minus 8. Okay. Now, we have like terms, so then you go one more step further and you can collect like terms. So if you do have like terms, you need to simplify your expression by collecting like terms. And so you get 15x plus 10. That would be your final answer. Example number 3, negative 8x, multiply it in. You get negative 8 times 1, and x times x, giving you x squared. Negative 8 times 3 will be negative 24x. And for the next multiplication, it's plus 2x. You've got to make sure you include that plus sign. Times minus 4x gives you negative 8x. And 2x times plus 2 gives you plus 4x. Collect like terms, the only terms that collect right here in the middle. And that's pretty common sometimes for only the middle terms to collect. And so you're adding, subtracting your coefficients, which we reviewed in our previous lesson. Okay. Question number 4, try it yourself, then check your answer. So multiply in, go. 10x squared plus 20x. Then the second multiplication, and make sure you include that negative sign. If you don't include the negative sign, you're not doing it properly. Negative 15x squared minus 3x. Collect like terms. Now it's a little neat. These two collect to give you negative 5x squared. And of course then these two collect as well to give you plus 17x. Now some higher end ones. Okay, 5 and 6 are challenge questions. So that's an extension. So now you have to multiply. When you multiply two different letters, all you can do is write them side by side to show that the multiplication still has to occur. Then you can multiply the same letters, watch your signs here, plus 18y squared. So that's definitely a harder question, isn't it? Multiply in, negative 10xy. We always try and write it alphabetical, makes it easier. A little bit of a system there to organize our work. And now we can collect like terms. So how many xy's are there? There are negative 22 xy's. How many y squareds are there? Well, 18 plus 16 would be 34 y squareds. And they're all positive. Okay, and so the next one, when you're multiplying the like letter, right? C times C4, you add your exponents, 1 plus 4 equals C exponent 5. So you're going to get 6 C exponent 5 minus 15 C cubed, because you add the exponents on the C's, and timesing by D, it doesn't get affected, it stays the same. Then you multiply this entire one in to get negative 8C4, multiply in negative 12C cubed D. So do you have any like terms? Well, the only terms that you can collect are these guys. So we will go 6c5 minus 8c4 minus 27 c cubed d. Okay, and you can switch those around in any order, but that one is going to be degree 5, degree 5, degree 4, degree 3 under C. So that's a pretty good order. As long as the coefficient's the same, then we're okay. All right, any questions you guys have?